Hello friends, today we will see one more cooling technology that is something special, and that is called steam jet injector cooling technology. So this is something different from the existing cooling technologies because there is some changes. So firstly we will see what are the components used in this mechanism. So here you can see this is the boiler, and there is control 1 valve, and this one is injector, where we have we use nozzle here, and there is a condenser, there is pump, and this is a flash chamber. Okay, so this flash chamber contains water, and this water we are going to cool. There is also a pump here. Okay, so there is some mechanism through which this is working. Okay, so there is some principle on which this mechanism is working. So what is that? That is the pressure and boiling temperature relationship. So we see what are those relations. See, when pressure of some fluid decreases, its boiling temperature also decreases. At the same time, when pressure increases, its boiling temperature also increases. So this principle we are using in this technology. So how this thing is working in this mechanism we will see. So just remember that as pressure decreases, so boiling temperature of a fluid also decreases. Okay, now see, we will see how this water is going to cool down. Okay, so we start from here. So water boiler, this is the boiler, and boiler we are using here to generate steam. This steam passes through this pipe, and using control valve we can regulate its flow. So when this steam goes through this pipe and enters into this ejector setup, what happens? There is a nozzle. We are using a nozzle here, and so firstly we will see what are our objective through all this step, all this setup. What we want that this is a chamber which contains water, and we want to decrease the pressure of this chamber. What will happen when we decrease the pressure of this chamber below the atmospheric pressure? As we have seen that when pressure decreases, the boiling temperature also decreases. Okay, all right. So if we are able to decrease the pressure of this chamber, the fluid's boiling temperature also will decrease, and it will reach its boiling temperature at normal atmospheric temperature also, and it will start evaporation. But as all the walls of this chamber are insulated, it will not gain any energy for evaporation. So that heat it will get from itself, and it start evaporating. So when evaporation will start, this liquid starts cool down. Okay, so overall we want that the pressure of this chamber should decrease, and that will start evaporation process for that water. We are using water here. So how we will achieve low pressure inside this chamber? The pressure we will go below the atmospheric pressure. So the steam will pass through this tube and enters into the ejector. Inside ejector, here there is a nozzle, and at just front of it, here you can see this is convergent and divergent nozzle system also inserted in this system. So when steam enters into the nozzle and it expands through the nozzle, the water receives high velocity using the nozzle. That velocity is so much at a high level that it reaches the supersonic level of the velocity. Sometimes it receives more than supersonic velocity. So at such a high velocity, the pressure of that location decreases rapidly. So that low pressure generation also decreases pressure of this chamber. So as our objective that we want a low pressure, so this ejector generates low pressure here. High velocity decreases pressure of this location, and that part is connected to this flash chamber, so it also decreases the pressure of here. So that much low pressure also decreases its boiling point. As we know that water starts boiling at 100 degrees centigrade when there is pressure of atmospheric pressure. But if we decrease pressure of the atmosphere, then the water will start evaporating below 100 degrees centigrade. So we can also generate evaporation at around 30 degree or 40 degrees centigrade, that is the atmospheric temperature. So that is what we want here in this flash chamber. So water start evaporating and it also start cooling, because when water is going to evaporate, it needs energy for that, and that energy it is achieving through evaporation. So water will evaporate, and that amount of that water which is going to evaporation will go with that steam flow. Okay, so now what is happening with the steam which is at a high pressure, the high velocity and low pressure? Okay, so we have achieved our objective here. Now what our cycle will go? So there is a convergent and divergent section. When the steam and the evaporated fluid, that is evaporated water, will pass through the divergent part of this ejector, the large cross-sectional area of this ejector will increase the pressure and decrease the velocity of that steam which was at high velocity. And also when at the divergent part, its pressure also increased, so it will start condensing here in this part. So that condensed and mixed steam part will go to the condenser, where it will extract its heat outside the system, and then the condensed steam, that is now water, will be pumped again to the steam boiler. So that's how this cycle will continue and will give us the cooled water. Here there is a section, there is an outlet where we can get the cooled water whenever required to us. So one more thing is there is written the make-up water. What is that meaning? This meaning is that when the evaporation occurs, then some amount of water will evaporate and it goes to this ejector. So there is a loss of some amount of water. That is generally around 6% of the water. So that loss of the water is fulfilled by this make-up water. You can also observing here that there is a spray system also involved in this diagram. So what it is doing, it is also helping to cool the water temperature level when it is coming inside. As the water cooling load coming inside, we use some spray nozzle to help this system to decrease some amount of temperature level of this water. So overall, this system is decreasing the temperature of this water. Thanks for watching.